Hi Year 12, we're still looking at logarithms. This video is going to flow on directly from the last one. I'll just move up to the top, which was review of log functions. I've just done it as two videos because it just worked out a little bit better that way. So these four log rules are ones that you have done in Year 11 and you need to memorize each of those. The way the rules work is very similar to your indices laws that you learn in the junior school. The first three here you will need to memorize. The bottom one, number 4, you will get given on your HSC formula sheet, and I'll show you that in a moment. So all these rules will pop in there as a base of a logarithm. The rules work for any base, as long as you understand how the rules work. We're generally working in the natural logarithm, base e. So most of our questions that we do will probably be a base e until we get up to 4, where we change our base. So if I have a log of a particular base and I can write that log's function in here as a multiplication of two things, I could split that up as log of that same base that I had up here of one of those parts in my brackets plus log of the other part in my brackets. Log of a base, and if I can divide my two things in my function, either they'll be given to you in a form like this, or you might have to work out what those two values are going to be. When it's divided, I'm going to subtract those two parts, so log of base x minus the bottom one, log of a of y. This third one is probably the most important one in here. I have log of a base a of x to the power of n. That n can be written down the front like this, and then it's n times log of a of x. That one we're going to use a lot, and that one is something that we'll have a go at down below. This fourth one is given to you on your formula sheet. It's the change of base rule. Now this one is really good. If we have a base here that is not a base e and we want to work in base e, we can change that to a base e by making where these b's are an e, and our x is on the top, our a is on the bottom, and it just changes that base from an a to whatever we pop in here, but generally that will be an e. Now I'm just going to jump over to the formula sheet and show you where that one actually sits on your HSC formula sheet. So in the logarithm section on that first page, the second blue formula here is our change of base rule, and that is given to you. So there's no reason for you to memorize it, and if you get stuck, you're just going to jump back in and look at that rule for us. Okay, so those are the laws. Let's go down and see how some of those are going to work for us. Okay, rightio. So if we had log of some base a of 1, we'd end up with 0. The reason being that a to the 0 is 1. Now before I go into that, I need to probably remind you of how to move between a log and an exponential. So if I have e to the y equals x, I'm going to think of that as my first, I might write it up here, my first thing, my second thing, and my third thing in that formula. And how we do change that to a log, we're going to pop out e is our base. We've got 1, then 2, and then 3. So that's number 1, that's number 2, and that's number 3. And we're going to think of it here as just going anti-clockwise, 1, 2, 3. So if we are given something in an exponential format like this, we can convert that into the log e to the y equals x, or we think of it as log of base e of x gives us that power of y. So that's how we're converting these ones down below a little bit. So if I show that first one again, log a of 1 is equal to 0. We're saying that a to the 0 equals 1, and that's where that comes from there. Okay. Similarly, if I had log a of a is equal to 1, I'm saying that a to the power of 1 equals a. So I can rewrite my log as an exponential like this. And I can do that for each one of those. So log of a of the square root of a, I can write as, and I might pop it down here a little bit further for you. Let's go. Log of a to the half. The half's going to come down the front, and I'm going to have half log a of a. A of a is 1, so I'm going to end up with a half. How I can also write that is that a to the power of a half is equal to the square root of x, which we've got there. We'll have a go at these down below again in a second so that they make a little bit more sense. But log a of 1 over x, I'm going to write that over here as log a of x to the minus 1. I've just rewritten that over here. My minus 1, this is our third log rule, comes down the front, and we end up with minus log a of x. So maybe I've gone through those a little bit fast, But what we might do is have a look at the examples down here below, and then we can go back and work through some of these if need be. Okay, our first one. I'll zoom in on those for us. Okay, so we've got log of base e of e to the 6. Using that third log rule, that 6 will come down the front, so we'll end up with 6 log e of e. We know that log e of e is 1. If you don't know that, you can pop that in your calculator, log e of e. I'll show you that in case you don't know how to do that. Remember, log e is ln. So, oops, where are we? So we've got, oops, my calculator's having a drama. So that's our log e. If I want to pop in log e of e, that will be a 1, like that. Closing my brackets, I'm going to get 1. So if you're stuck, you can always pop that in there. But thinking what my log rules mean, that log e of e, that's saying, well, e to the something equals e, and that's going to be 1. There's a few ways to think about that. So log e of e is 1, so we've got 6 out the front times 1, which gives us 6 as an answer. Let's look at the next one. A little bit. Okay, for our second one there, log e of 1 over e. We're going to write that like this, as log e of e to the minus 1. Using log rule 3, the minus 1 comes down the front, so we end up with minus 1 log e of e. Log e of e is 1, so we end up with minus 1 times 1, which is just minus 1. Let's look at our next one. Okay, pause it if you need to have a look through these yourself. Now, I'm going to be writing this part, the function, as something that is workable. So I'll have log e of e to the minus a half. Remember, the minus means that we've been down on the bottom line, and the square root is the half. The minus a half comes down to the front, so we'll end up with minus a half log e of e. Log e of e was 1, so that's where that 1 comes from. And we've got minus a half as our answer. Again, pause it if you need to. Lucky last, this one's on our formula sheet. You should either be able to look at that and go, the answer's 10, or you're going to refer to our formula sheet, and I've got the formula that we are using down below. So this is the one that we're given on our formula sheet. Ours is taking that format there. A of log a of x equals x. We have something of that form. E of log e of 10 must equal 10. So we've been given that one straight up. Fairly simple. So again, you may not remember these, so you may need to go back to some of your work from year 11 to have a look at these. Now, I'm going to give you 2 methods for this one. I'm probably recommending my first method, but there's always generally another method to do these. Okay, so it's saying use logarithms of base e to solve 2x to the power of 100 to 3 decimal places. My method 1. Method 1 is going to give me, well, I want you to rewrite this exponential form in a logarithmic form. So what I've done is said, well, what does that mean? 2 to the x equals 100. That would be, thinking of our numbers, we went 1, 2, 3, and in log form it's 1, 2, 3. So if this was our 1, that was our 2, and that was our third term, in our log, that's our first term, that's our second term, that's our third term. So we're just popping them in like that. So I'll end up with log of base 2 of 100 is equal to x. I need to find my x. I have our log of base 2, so I can use my change of base form to make it a log of base e, which I can calculate on my calculator. Likewise, you could probably do a log of base 10. That would work as well, but I'd prefer if we actually just stick to base e's. So using that formula on your formula sheet, there it is below. I'm going to change this base to e, and the formula says I can pop the number here on the top and the number here on the bottom. So I end up with 100 on the top, 2 on the bottom, and I'm log of base e. And it wants me to do that to 3 decimal places, which is going to be working out to be 6.644. Now, there is another method. If you do not like that method, or if you find that you can't remember the order that the logarithm is supposed to be in when we're changing it from an exponential, what you could do is you could take the log of both sides. You don't need to use this method if you don't want to. I'm giving you the option. So if we were to take the log of one side and we do the same to the other side, it's going to work. So all I've done is just taken a natural log of 2 to the x, and that's going to be equal to the natural log of 100. In doing that, my power of x comes down the front, so we end up with x log 2 equals log 100. And then what I can do is just divide both sides by log 2, and I'll end up with x is equal to log 100 on log 2, which is the same as what we had before. It's just another option. where we don't need to know how to convert between the two. Okay, question 3 here. We've looked at ones like this before with substitution, and I'm pretty sure we had one in a past assessment task. They're very common, and we will see them again in our next topic where we've got trig functions like sine or cos in there. If you're getting a question like this and it's saying use the substitution of u equals e to x to solve this equation, we need to be able to, you can substitute it in, and hopefully once you've substituted in, you'll get a form that is something that you can see or understand what it looks like. And I might do that first before I explain it, but if I was to substitute u equals e to the x into here, I'd end up with 3u squared minus 11u minus 4 equals 0. And what I end up there with is a quadratic. So perhaps you've noticed that this question right at the start looks like a quadratic, perhaps not. But whether you have or not, it's going to end up with a quadratic once you substitute that in. Okay, so I'm going to assume that we do remember how to factorise non-monics. If not, then you'll need to pause the video and have a go at that. But I've factorised mine this way. If you're splitting yours up into pairs, you're going to end up with the same as me, and you're going to end up with u minus 4 and 3u plus 1. In doing so, I set each bracket to 0, and I end up with u equals 4, and I end up with u equals minus 1/3. I think we should be all able to get up to this point here. Now, noting that I originally substituted in and let u equal e to the x, I need to pop that substitution back in because we've ended up with a solution for u. However, our equation wants us to solve it in terms of exponentials and wants us to solve for x. So we don't have an x where there's a u, so I need to pop my e to the x back in. E to the x equals 4 then, and e to the x equals minus 1/3. Now, in looking at that, the first thing I would like to note is that if you think of what the graph of e to the x looks like, that never ever goes below the x-axis because the x-axis is an asymptote, so we're not ever going to have negative values of e to the x. So I don't have a solution for that part, but I can find a solution for e to the x equals 4. Now, I've written a note over here. You can use either method from the previous question to answer this. You can either take the log of both sides and solve for x, or you could get that into a logarithmic form and solve for x either way. So I want you to pause the video and see if you can solve that one for me. I've done it by taking the log of both sides, but again, you might want to use the other method by getting it into its log form. Either way, we're going to end up with x is equal to log of 4 as our answer. I ended up with this format here where my x came down the front. I ended up with log of 4 of log over on top of log of e. You would have changed your base to e using the change of base formula. Perhaps you would have ended up with the same. Log of e of e is 1, so I ended up with log of 4 on 1, which is log of 4. So that's where my answer has come from. Okay, now that's a fairly complex question. Your textbook is going to ask you to do a heap of those. If you jump into the OneNote, I've started working through some of those in 5F for you. So when you get to question 10 and question 11 and you're stuck, or if you do get stuck, come through here and have a look and see if I can help you out with some of my solutions. Okay, thank you.